The first part is showing Pythagoras using grid paper and using a triad, so where the side lengths of our right angle triangle are whole numbers. So before we start this, remember that Pythagoras is a squared plus b squared equals c squared. So that's what we're going to be proving. Okay. Now part 1 is using grid paper, as I said, to show a 3, 4, 5 triad, where 5 is the length of the hypotenuse of our triangle. Okay. So what we need to do is draw a triangle with a base, a right angle triangle with a base length of 3 units, a height of 5 units, and then we're going to show that the length of the hypotenuse, okay, our longest edge, is actually 5. And that when we square our base length, and that's why we've drawn a square there, for b squared, and we square our side leg, and there's our squared side in red, when we add them together, they'll actually equal the hypotenuse squared. So a squared in red is 4 squared, and that equals 16 units. The base is 3 squared, and you can see that that's 9 units. And we're going to show that those together added up will equal the hypotenuse squared. So we're going to cut these out and cut out each shape. Cut out the triangle, the green square, and the red square. Now I've actually gone next step where that b squared, the green squares that equal 9, I've actually cut into another 4 pieces. Because what I want to do is actually want to place a squared along the hypotenuse and then rearrange b squared around a squared, or the red. Like so. And you can see here that it fits nicely along the hypotenuse. Well, there's a little bit of a gap here, but I think that's just from at the bottom. I think it's just a bit of overlap in my grids. So c squared is 4, with a length of 4. And then when we arrange b squared around it, it makes a new square, which we're going to call c squared, and that each side of our square, b squared, has a length of 5. So we can show that that's the length of our hypotenuse. Let's have a look at all this together. B was 3 units across, A was 5 units high, and C we showed A was 4 units high, and C we showed was 5 units long. If we set it out like this, then a squared, that was our side, length of 4, has an area of 16, or 4 squared, plus b squared. B had a length of 3, so b squared, that square, is an area of 9, or 3 times 3. And when we add those together, 16 plus 9 is equal to 25. And if we count the squares in c squared, they do in fact equal 25.